So if I say a sign that says Apple Market, Clip will give you some things that loosely associated with that text. So here's a sign. There's Apple somewhere on this sign. This has the big apple. So it's sort of related, but the first results from P are all exactly what you asked for. So like a sign that says Apple Market. And you could even do compositionality. So maybe like a red sign that says Apple Market. And P's first result will be that red sign.
Sometimes you're looking for an image or a video with really specific content, like packages loaded in a delivery vehicle. You hit search, and some of the results that you see might be exactly what you're looking for. Some of the other results might be a little bit different. Well, recently, a team at Meta released a new model called Perception Encoder, which may drastically improve some of the results that you see not only from image search, but many other tasks that require visual understanding. And today, we're going to be learning more about Perception Encoder and comparing some of its capabilities to other models like CLIP. And to help us learn more about Perception Encoder, we are joined by Daniel Bolya, who is a research scientist at Meta and was a major contributor to the project. Daniel, would you like to say hi to everybody and introduce yourself?
Yeah. Hi, and thanks, Patrick, for introducing me. Nice to be here, and I'm happy to explain anything about Perception Encoder and how it works.
Nice. Okay, welcome. Thank you so much for joining us. We are also joined by Peter Roboflow, who is the machine learning lead here at Roboflow. Peter, would you also like to say hi?
Yeah, hi, I'm Peter Robisha. I've worked a little bit with Perception Encoder, building some fun demos using the model, and just overall a big fan. I have a little bit of experience with it.
Nice. To get started, Daniel, I have a lot of questions for you. Would you please just let us know what is perception encoder? What's an embedding? What are we looking at here?
Yeah, so Perception Encoder is a family of vision encoders. Basically, vision encoder is what takes an image or a video and maps it into an embedding or a vector of numbers that a model can understand down the line. And so vision encoders are basically a core component that sees the world and translates it to some like sort of semantic understanding that our models can recognize. And P comes in three flavors. The one we'll be focusing on mostly today is P core, which is sort of the backbone PE. And that is trained to align images to text. So as you can see in like the top left example, P core out of the box can align an image, for instance, this cat sitting on some grass, to a line of text that sort of describes the image, like a judgmental cat sitting on the grass. So P is actually very good at sort of aligning the representations of the image to a corresponding text. But there's also two additional models that we won't be sort of covering today, but that can be used as components in sort of downstream machine learning architectures. For instance, P language works very, very well on language modeling tasks. So if you're building a language model and need a vision encoder for that language model, P language is a very good choice for that. So that would be tasks like OCR Q&A, like trying to figure out what these bikers are holding up, what that spells. So like in this case, it would be Indianapolis. And then we also have P spatial family of models for directly spatial tasks that don't really rely on text. So this would be things like detection, or in this case, you can see this depth map that was generated by the model. So with those three family of models, we sort of cover a lot of use cases that you would need for vision encoding. And I'll hand it back to Patrick.
You know, in my history here with doing live sessions at Roboflow, we've had a lot of dog examples in our sessions. I think this might be the first time we had a cat example, which is a little bit surprising to me. So, thank you for that. Daniel, I had another question for you, which is, could you tell me a little bit about, I guess, like the background of perception encoder? What was the motivation? What was perhaps the problem that you saw out in the world of models that you wanted to solve here?
Yeah, so there's kind of like multiple classes of vision encoder. So the main class that perception encoder is supposed to fall under is the clip class of encoders, which is trying to match images and text. That's what sort of PE core is. But a big problem with those encoders is that they only work for that specific task. Like if you wanted to use a clip encoder for like, let's say detection tasks, it's actually like not so good compared to something like, let's say a dyno encoder or something specifically trained for detection. So one of the things we wanted to set out to solve is try to find one sort of base encoder that could be used downstream for a lot of different applications. So like language and also spatial, in addition to the original clip tasks. So one of the things we tried very hard to do is making sure that, our PE core can still be used downstream for these other tests. And we weren't, 100% successful in having one model that does that. But we were able to come up with some techniques to make sure that the base core pre-training step is actually as general as possible so that it can be later easily tuned for language and spatial down the line.
I have one more sort of basic question just about like what is perception encoder, and that is, could you tell me a little bit about sort of, I guess, the different sizes that are available,
Yeah.
sort of the scale of the model, like how huge is this thing? How small can we get? Things like that.
Yeah, so the base perception, like the biggest perception encoder model is quite large, so almost 2 billion parameters. But we have releases down to all the way to tiny. So tiny can, run on your laptop and stuff. And all of them are sort of distilled from this big model. So they're all actually fairly good compared to other, tiny clip models in the past. One thing I didn't mention before is like PE core is also trained on videos as well. So previous like clip models and stuff are trained on only images, but that's actually jointly the same model works on both image and video.
Well, so speaking of using PE on different kinds of images, videos, and kind of getting to know the capabilities, I want to go to our next slide here. And Peter, I was hoping that you could let us know a little bit about what's going on in this image. I see, of course, there's an image of a guy with a beard. There's some text. There's like a similarity percentage. Could you explain what we're seeing here?
Yeah, so in general, the class of clip models that Daniel referred to is at the main sort of task that the model is trying to achieve is aligning text and images. And so what that means specifically is you take the image and you map it into the same sort of space that you map text into. And in that space, you can compare the two vectors and see how similar they are to each other. And this demo I built shows running PE base. And the caption at the bottom is sort of a predefined caption that I wrote, which is an image of a guy with a beard, or a guy with a beard holding a can of sparkling water. And then we embed that text and embedded the image in real time and sort of looping over the image, see how similar that image is to that text embedding. And so the cool thing that you can see here is that the model understands this text, and the higher, the more that the image conforms to that text, the higher the similarity is. So you can sort of imagine using this in a lot of ways to like detect when whatever image you're looking at is similar to whatever description you're looking for.
I have one more question about this, which is for the similarity, 59.8%. Like, is that a good score? Because for me, my human eyeballs, I look at it and I think that's 100% an image of a guy with a beard holding a can of sparkling. Like, I mean, well, I don't know. Maybe I shouldn't make assumptions. Maybe like 99% sure. But yeah, could you tell me a little bit about like the similarity score, and is that good? And is actually even good a term that I should be using here?
Yeah, that's a really good question. So I would encourage whenever you're building an application trying to compare text and images to sort of calibrate the sort of what the maximum similarity you'll see and what the minimum is. So an interesting sort of research problem that all clip models face is that because you're embedding the text with one neural network and you're embedding the image with sort of another joint neural network, you never achieve sort of perfect alignment of features. Basically, although the loss is encouraging images that are aligned with a caption to be as close as possible, usually there's sort of a gap between the space between where images occupy and images and text embeddings occupy. So basically, I would say that this similarity score is sort of like a it's usually the better a model is, the better it preserves the sort of ordering of similarity, but it doesn't necessarily range from 0 to 100 all the time.
Nice. Daniel, did you have anything that you wanted to add to that?
Yeah, I think Peter's explanation was pretty spot on. Basically, during training, there's actually a huge set of text in that the model has to compare to a huge set of images, and it has to sort of map them one to one in the training loss. And this is actually a very ill-defined problem because like one caption can apply to multiple images. So a lot of clip models will be actually fairly conservative with the similarity statistic because it can't like really jump the gun and say 100% when there might be another image in that batch that sort of describes that or has that same caption or could have that same caption.
Cool. I wanted to bring us back to this topic and comparison of image search capabilities in different models. Here we have like a video playing of some tests that I did on a tool that Peter and Daniel built to help compare image search results from Perception Encoder versus Clip. And I think at this time we're going to switch over to Daniel's screen, and he is going to actually be able to go through some of these queries with us, and we're going to take a look at how the results vary. So Daniel, if you want to go ahead and take over the screen sharing, I will stop sharing my screen. And then for our viewers, if you are interested in a specific query and you want Daniel to try it out in this demo, feel free to leave a suggestion for something that you want to check in the chat here in Zoom. So with that, Daniel, I'll hand it over to you.
Okay, great. So a little explanation of this demo. So I'll search here like orange berries. And on the left will be results retrieved with clip. So this is like based on the highest so clip similarity between this text string and a set of like a couple 100 million images. And on the right will be perception encoder for the same model size. And immediately when you actually start playing around with this, you'll notice that perception encoder has a couple of capabilities that if you use clip before, clip does not. So the first thing is compositionality. Clip is very, very notorious for ignoring compositionality in text. So what I mean by that is like if you search orange berries, the first result from clip is not orange berries, it's oranges and berries. So it just kind of ignores that the orange is modifying the berries and gives you an image of both of them. While on the other hand, perception encoder is much better at like respecting compositionality. So in like all of the images that perception encoder returns, you see these orange berries, which like before I did this demo, I didn't even know existed. But perception encoder is able to find them, while clip just gives you a bunch of oranges. And sometimes oranges and berries in the same image. So in general, perception encoder represents compositionality very well. For instance, if I say a blue street sign with white text, like the first result that clip gives is a street sign with a green black background, not the blue that we expected. It gives this sort of one street sign here, but most of these are just like very like photogenic images of street signs that don't like respect the actual query that we asked for. And first, the first one that a PE responds is kind of a little bit wrong, but the rest are like basically all spot on of like what I asked for. And so in general, perception encoder is a lot more robust to these sorts of things. And this includes robustness to like more hard images. So if I search like a raccoon at night, clip will actually spot on, it will understand what you mean. So it will understand like a raccoon at night and give you that image. But the second anything is bad and like is hard in that image. So for instance, like there's a bunch of night vision images in this data set. Clip will completely fail. Like, so it doesn't recognize the raccoon here. This is actually a possum. It's not a raccoon. And you can see clip returns a bunch of images of possums. Like this one's also a possum. So like clip actually just fails in identifying what this object is because of the adverse settings of the image. Whereas perception encoder is able to correctly identify raccoons even in night vision. for instance. So these are all images of raccoons. And another thing Perception Encoder is very good at is text. So if I say a sign that says Apple Market, Clip will give you some things that loosely associated with that text. So here's a sign. There's Apple somewhere on this sign. This has the big apple. So it's sort of related. But the first results from P are all exactly what you asked for. So like a sign that says Apple Market. And you could even do compositionality. So maybe like a red sign that says Apple Market. And P's first result will be that red sign. Whereas like, clip is just, give you a red flag. So in general, P is a lot better at compositionality. It's a lot better at text. And it's sort of a lot better at understanding more difficult images. And that's that's like a good point to pause to maybe, Patrick, if there's any queries from the audience.
Yeah, we do have a few. I was going to, should we start from like simplest to hardest or hardest to simplest? So there's one from John, smoke detector, just 2 words.
Smoke detector, let's side out. Interesting. But this is, the cliff gives you smoke.
Mm-hmm.
And then P gives you, I don't know what this is. I'm not sure if there's, oh, is this a smoke detector? Sure. It might not be in the data set, by the way. So this, this demo is sort of constrained in sort of what images are actually in the data set.
Yeah, I was about to say the same thing, that sometimes we find images that are just completely missing from the data set. How about, there's another one from Daniel, 12 men in the factory.
Oh, we can't do numbers in this one, so I have to do 12. Yeah. Well, I don't know if this is 12. So what I will say is P can count up to like 3 or 4. I think this is 13 if I counted correctly.
I see one guy.
No, this is 12 actually. Yeah, this is 12.
Yeah.
Hold on. Okay, I did not expect this to work actually. Oh yeah, there's a couple of guys in the background, but I think like the main people are 12. But in general, PE can count up to like a couple. So like if you say 1 cat and 2 dogs, oh, you can't do and. This is two cats and 1 dog. Yeah, but basically, let's say actually I did this query before. 2 dogs in a car. So P is able to generally, if the image exists in the corpus, sort of count up to a few, and actually respect the compositionality of the fact that that's in the car. Whereas clip can sort of count to 2, but in most cases, these are actually pretty good too. Yeah.
All right, we have another one, which is 3 boxes stacked on top of each other. This is from James, and I'm wondering why he needs this image.
Oh, you got 3 boxes. These are, I guess these are, I don't know if these would be considered to be debatable, but yeah, general seems to work. Yeah, I would be confident P can kind of count up to like 3 or 4. And then clip is, yeah.
I had one that I tried out earlier, which was, I think I wrote like an athlete kicking a soccer ball.
Oh, how do you spell soccer actually?
Now you've broken my ability to spell.
It's okay. We got spell check for this. We got spell check for this. It's fine.
We'll just edit out that part out later.
Yeah, of course.
And something, if you scroll down a little bit, like some of the results are different, like with clip, like sometimes it's like not a soccer ball, sometimes it looks kind of like a ball. And then if you go over to Perception Encoder, you click like somebody kind of like winding up, about to kick the ball. I don't know how you explain this, or I'd be actually curious from your side, like I find the perception encoder results like more aesthetically pleasing. As a researcher, like how do you try to explain that, or have you had any
Yeah.
observation related to that? Like it's kind of like they're just more entertaining or more interesting to look at. Like,
Yeah, so that's
how do we talk about that?
That's actually probably because Perception Encoder is trained on videos as well. So, of course, in this demo, we're only doing images, but you can do the same mapping from videos to text. And Perception Encoder does have like a step where we train on very well annotated videos. And in videos are all about sort of the action shots. Like that's how we actually like in our video data set, we filter by videos with specific like actual actions. So P will understand actions probably a lot better than Clip because Clip has only seen actions through the lens of like images, where P has seen it through videos.
There's another one that I kind of started off with here, which was like, I think I was searching for like packages loaded into a delivery vehicle, or maybe even just packages in a delivery vehicle. Yeah. And this one I thought was a little bit interesting because I see there's definitely like on the Clip side, there are delivery vehicles, and then there's
Yeah.
packages, and maybe there's also just like a weakness of my query, right? Like, yeah, okay, yeah, technically that is packages in a delivery vehicle. In my mind, I was kind of hoping to get the perception encoder results over there of like it's a van or a truck.
Yeah.
Yeah, right. But I think my takeaway here is it's like the perception encoder was a little bit better at kind of like guessing what I needed or
Yeah.
like making up for my poor query.
I think that's it in general because of the compositionality aspect. So a lot of time Clip will treat your query as like a bag of words. So it will just consider each word independently. So when you say a package in a delivery vehicle, it doesn't really care about in a. It only cares about packages, delivery vehicle. And then so it gives you results with delivery vehicles and packages. Whereas perception encoder can a lot better represent sort of that the fact that it's inside of a delivery vehicle, which is why I think you see much more images inside it. But I'm wondering if like yeah, so even in this setting, if you very spoon feed the query to say like a van with packages inside of it, this is very much not like I mean this van could have packages inside it, but we don't know, right? So the Clip is just ignoring the packages part of it and just focusing on the van, whereas P is able to like union the two together.
All right, beautiful, very cool. Um, Let me see here. Do we have any other queries? I didn't see any other
Oh,
suggested queries from the audience. Did you want to demo anything else? Yeah.
yeah. One thing that actually is very surprising, like after like we didn't try for this during training, but it ended up just working. In that P is very, very good at like recognizing like geolocation. So like recognizing what country something is in just by the image. So if you do like a Canadian food truck, which is something I really like to do. Um uh this isn't a food truck, but so Clip will just like sometimes give you Canadian food trucks, and mostly just not give you food trucks. Um, yeah, but I don't. This doesn't seem like a Canadian specialty to me. Um, but P will give you like explicitly find some way to connect this to Canada in the image, like whether it be a Canadian flag, whether it be well another Canadian flag, or I'm trying to look for a poutine truck. Yeah, a poutine truck. Somehow it'll always find it. And I've looked at like running this on like a bigger set of images, like billions of images, and it will find like the smallest little details to map that to the fact that it's in Canada, like a .ca URL on the side of the food truck somewhere in like very small font or something like that. So it's always like very surprising to me that they can find these things.
Yeah, I see one of our viewers suggested searching for something like a car with a Canada number plate or a Canada license plate.
Canadian. Let's see. I don't actually know what Canadian license plates look. This is not. I don't
Might
think
also
this is
change.
illegal. Yeah.
Yeah, well, it might also change depending on, I guess, the province. Maybe we should search for like a
Yeah.
British Columbia license plate.
Oh, but these Vermont is not Canadian, but it's close. This is Ontario, so this is actually correct from the clip side. This is also a GIST Vermont image. What is that? I can't read the actual license plate, so I don't actually know. This is Ontario.
It might be a limitation of our data set that we're looking at here. Oh, that looks like British Columbia.
Yeah, like Swiss mountain side. I think I did this before. Yeah, I don't know. But this, yeah, helps. Yeah, I think Clip is good at that too. It's just in general, like actually PE is sort of the state of the art by quite a bit on like GeoGuessr type questions. Like even compared to the other state of the art Clip models out there.
All right. Well, I think for now we could always return to this later if we get some other suggestions, but we could sort of continue on to our next topic.
Sounds good.
I'll go back to sharing my screen. Thank you very much for that demo. Let me rearrange a couple things. Yeah, so we can move on here to if you are a user of Roboflow and you're interested in how Perception Encoder might be applied, within the Roboflow ecosystem, I was hoping that Peter, you might be able to tell us a little bit about the tools that are available for people at this moment.
Yeah, so we added Perception Encoder to Roboflow's inference package, which is a package that allows you to run a bunch of different model types, either sort of on your own hardware, on your computer. It has a client to Roboflow's web services, so you can make requests to our hosted inference services and run sort of larger models there. So that demo that we showed earlier in the presentation was built using the code that's displayed on the screen. So not a ton of code to write like sort of a streaming webcam version of the PE demo. And so if you're interested in trying out PE for yourself, you can just pip install inference and, copy and paste this code. And you can also use sort of PE in other contexts where you'd use Clip that way.
Nice. Now, with that said, I was hoping to have sort of like one more kind of big topic before we wrap things up. And this relates to the possibilities, applications that are either unlocked or improved by having Perception Encoder. And I guess to give a little bit of context, I work in marketing. I make web pages, I make slide decks, I make webinar content, video content, and I often find myself on stock imagery websites, and I'm searching for really specific things. Like, I want to do a webinar about finding damage in shipping cartons or shipping containers, and I'm sure that the stock website, they must have videos of these shipping cartons that are damaged, but when I search on their website, I can't really find them, and then I end up spending a whole lot of time sifting through results myself. So if anybody from some stock websites, they see this call, this video, please get in touch with us, and perhaps we can help improve the search results for you. But that's my example of how I could see something like Perception Encoder improving like a real world use case. Daniel, I was wondering, have you seen Perception Encoder used out in the wild? Or maybe this might even just be something you built yourself, you're using yourself, or some other projects that you've seen people do.
Yeah, I think actually there are a lot of applications very similar to that. So not just like, I want to find a specific example of a picture, but as like a tool in the pipeline for training your own ML models, one of the big things is like, which data do I annotate? How do I find like images or videos to annotate that are sort of relevant to what I'm trying to solve? And a lot of times you'll have a big set of images and you want to find like specific maybe failure cases of your existing model, or some specific concepts new concepts that you want to annotate in your data. And I've seen a lot of success using Perception Encoder to be able to do that search and filtering. So I mean, like in the demo, you could just do like a search with a text query, but you can also take, an existing corpus of images that you've already hand selected and like sort of average the embeddings together and search with the image embedding instead of the text embedding and just get a bunch of similar results. So this is not only can P, do text-based search, but you can also do the reverse, right? Sort of image-based search. And that is just really, really useful to finding more examples of failure cases that you want to annotate, or more examples of a rare concept, for instance, that you want to annotate. And that's been, I think, used for very big success in some of our other projects.
Cool. All right. Peter, I was actually hoping to ask you a similar question. I think you have a lot of experience kind of interviewing people, chatting with people who are using computer vision, kind of like out in the world at work or for their own personal projects. What are some of the cool ways that you've seen people use models like this?
So I think that, sort of retrieval is like the obvious thing. But I think in general, sort of like any use case where you want some sort of semantic understanding to be built into sort of a downstream flow makes a lot of sense. So you can imagine sort of like similar to the way this demo was built, you like upload a bunch of images on the fly, and then you sort of process them into just like their perception encoder vector. And then you sort of have this representation that you can use to both sort of like look for similar images in a data set or like search over text. Other instances that happen in the research world is, I mean, so PLM, perception language model, I think, is the language model that was built using perception encoder text as a base. But because it has sort of more robust vision and language features, it's a good base to start building other models off of.
Let's keep moving ahead because I saw we have a lot of questions and I'd like to leave a little bit of time for them. Before we start to sort of wrap things up and move on to questions, Daniel, do you have like any other announcements or things that you hope the audience would be aware of?
Yeah. Keep a lookout. There's going to be some cool new models dropping pretty soon. Some using Perception Encoder, some maybe adding some new capabilities to Perception Encoder. So look forward to that. And yeah, Perception Encoder, I just recently learned was accepted to NeurIPS as a like top 1% oral at in December. So I'll be both at ICTV and NeurIPS if you want to chat.
Beautiful. Congratulations on that. And I won't be there myself, but I'm sure there will be some people. So please, if you're at those events, stop by and say hi to Daniel. So with that, I was going to take a quick break and say if you're watching a recording of this session somewhere and you want to join a session live in the future, please head on over to roboflow.com/webinar and you'll see a calendar of some upcoming events that you can join in the future. And also, I want to move over to some questions, and I'll do my best to sort of rephrase things and make it easy for everybody to listen in and understand. But really early on, there was one question that we had from Eric, and he said, Clip is often used as a feature provider in object tracking applications. Are you aware of the use of perception encoder for this kind of problem, especially for pedestrian tracking? So, do you kind of have anything that any guidance that you could provide there?
Yeah, I think for any task where you're already using clip vectors, P is just a drop-in replacement that improves performance. I've seen works that like use clip-like models for like zero-shot tasks that have replaced their model that they were using with P and instantly getting like a 7-8% accuracy improvement. So basically, anywhere you use clip right now, you can just slot in PE and immediately get a boost in performance for most things. And as for pedestrian detection specifically, if you wanted to sort of swap out like maybe the backbone encoder that you use for your pedestrian tracking instead of just the sort of the clip embeddings, you can also maybe try out PE spatial as well.
Cool. I'm going to jump around a little bit, but I saw one question that intrigues me. It was about the size of PE and compared to clip, and they were wondering about, how does it work if I wanted to say deploy on a smaller device like a mobile phone? This person said it was John, looks super interesting. And for our use case, they're using Clip at the moment. Could you talk about that?
Yeah. So I think the smallest clip model that has been released has been like clip base. We actually released two additional smaller models that are even smaller. So we have PE tiny and PE small. And so those ones are actually like fairly lightweight. Like I think PE tiny, I'm not exactly sure on the parameters count, but around 10 million parameters. And for clip models, like there's no like it's the RP tiny model is like 10% better on most metrics than any other tiny clip model to date. So definitely give that a try if you want to sort of deploy on like very small use cases. And I think that should work plenty well for you if you are already using clip base.
We should also think about how we get that tiny model working in Roboflow as well. It might be useful. Um, there's another question here from Mongal. And this one's kind of cool. He said, can the could we talk a little bit about like the intent-based outcome of the search? So this probably came in when we were doing the demo. And he said, for example, if I search for I am hungry, then provide pictures of food or food restaurants and not the text itself, to sort of understand the intent behind the search. Are there any capabilities like that? Have you tested that out in the past?
Yeah, so what I will say is that PE and most clip models are trained on like web alt text. So that is like when you upload an image and you want something to like some text that describes the image to display when the image can't load or if you can't like someone can't see the image. So basically what the model is trained on is what a human would write about an image. So in a lot of cases, that actually might be intent based, right? So if you upload an image, you might like caption it, I'm hungry and show a picture of a nice burger or something. So those sorts of things actually P and Clip actually both do, I think, fairly well. So yeah, I think it should be able to, especially anything to deal with food, like anything people would like generally upload to the internet a lot.
Nice. Yeah.
Yeah, actually, one of the demos, yeah, one of the demos I have is like, a cat that's like mad at you or a cat that really wants food, and you can see that the P is able to sort of understand that. With a cat that wants food, um, sort of it's in a kitchen looking at you really longingly, is that what P returns. So it sort of understands the underlying semantics, but it's basically, modulo what people actually upload online.
Cool. All right. I'm gonna merge a few different questions together. But when we were showing off that sort of proof of concept demo website that was designed for this presentation, there were sort of like a lot of questions about, is it possible to see the confidence results? Kind of what's the database that we're using to get the images? Can we see cosine scores in real time in the demo? I don't think we're going to update the demo right at this minute, but I guess when you're creating your own app or when you're deploying PE, I'm assuming that there's probably ways for us to see some of these scores. Could you talk about that?
Yeah, so basically, in order to actually show these results, you need to calculate like the cosine similarity score, right? So all of these results on the demo are basically sorted from highest similarity to lowest similarity. So the first result will be sort of the highest similarity. One thing I will caution is basically what Peter said earlier. These models never will give you 100% similarity. In fact, like most of the time, if the query is very short, it will give you like 23%. So you'd have one thing that will be like 23% and one thing that will be like 10%. And then it will get it correct, like the ordering is correct, but the actual calibration isn't the same. So if you are deploying this on your own task and you do want similarity scores, you should run the model beforehand on some test data and figure out how to calibrate the similarity scores from what the model does on your test data or your training data.
Beautiful. Yeah. I remember a colleague was working on a website where, what was it? It was the Timothy Chalamet comparison where you upload a picture of yourself and it tells you how similar you look to Timothy Chalamet. That's his name, right? Yeah. And I remember he was tangling with this issue of sort of deciding how to interpret the score and improve that. And sometimes it's the beauty is in the eye of the beholder, or the Timothy Chalamet lookalike is in the eye of the beholder. Let me see if there's any other questions that we should be getting through here.
I saw a question about, is it possible to fine tune?
Oh yeah, please, thank you.
I imagine Roboflow will also have like a way to do this, but right now PE is actually integrated into OpenClip. So like this the standard way people sort of train clip models today. You can actually go and use it as a like right out of the box from OpenClip and start fine tuning right now. Yep.
Cool. Yep, that was definitely on my list. I'm gonna take one more out of here, which is from Daniel. This is actually something that I was thinking about the other day as well, but so he said, have you ever seen Singularity break through performance when training PE with large scale sizes? Any specific differences between the weight size and performance? Is there kind of anything that you could share here about like the process of training a model like this?
Yeah, I probably wouldn't say singularity. I think that may be a little bit too strong, but definitely there are things that work at larger, both larger model sizes and larger resolutions that don't work in smaller resolutions. So some things like the compositionality, we only started seeing that when we, trained on a large model and with a specific way to train it that we describe in our paper. Um, and we don't you don't see that on the smaller clip models, but it turns out that you can distill it back into the smaller models after the fact. It was very interesting, the dichotomy there. So like the bigger model sort of discovered how to work well on OCR and how to work well on like the more compositional structure of text, which you can distill back into the smaller models, but the smaller models don't find that on their own. Like, in fact, one of the very interesting things is our text encoder is architecturally identical in both size and like number of parameters to Clip's text encoder. So in that demo, the text encoder sizes and architecture were identical. Yet the text encoder in PE, that PE model can understand compositionality, while the Clip one cannot. So that is like just some thing that just like a switch flipped because we train a big model in with a specific training recipe and distilled that back into the smaller model, and then now can just do that. So I think that's pretty cool. What we found.
All right. Well, I think that we are out of time for today. So thanks to our viewers and audience members for submitting all of these questions and coming to watch this session. And thank you very much to Peter and Daniel for agreeing to join and teach us a little bit more about perception encoder, visual understanding, and what you have going on there.
Thanks for having me. It was great.